fingers together, try to place them underneath the center of mass. When they let go, you will find it doesn't normally work. But now try putting each index finger at opposite ends of the cane and then moving your index fingers in towards the middle. What you will find is that they always end up right under the center of mass of the cane. You can try starting off asymmetrically, and they will still end up under the center of mass. You can try going at different speeds, really slowly, or really fast. But you still end up perfectly under the center of mass. How does this work? Number 2, the phone flip. Have you ever tried to spin your phone? If you do it in this direction, it's pretty easy. It stays nicely aligned. If you spin it along its short axis, you'll also find it spins very well. But if you try to flip your phone end over end like this, you can't do it cleanly. The phone will never flip simply end over end without also rotating in one of the other directions. Even when I make an almost perfect flip, instabilities grow until the phone rotates around another axis. Why can't... No, I still can't do it. Why is it so? Number 3. You've probably seen that if you rub a cup on your hair, you can make it electrically charged, and if you bring it close to a stream of water, you can actually cause that stream to deflect. Now, usually this is used in chemistry textbooks as a demonstration of the polar nature of water. Water is a molecule with a more positive side and a more negative side. And so what happens, so you're told, is that the water molecule flips around so the positive side of the water faces the negative side of the cup, and that is what attracts the water to the cup. But this is not the real explanation. If you have a uniform electric field, there's an equal force pulling the positive side towards it as there is pushing the negative side away from it. And so you can't actually do more than just turn the molecules. You would need a really, really strong gradient in your electric field to make this work at all, and it basically is just not going to happen from a cup. So why is the stream actually attracted to a charged cup? That is the question. Number 4, take a piece of your favorite cereal and drop it into a bowl of water. Then, using a very strong magnet, try to pull the cereal around. Isn't that cool? So why is cereal magnetic? And finally 5, the tea bag rocket. Take a tea bag and cut off the sealed end very carefully. Now dump out the tea. Form the tea bag into a square column and balance it on the plate. Now light the top of the tea bag on fire. Try to light it evenly on all sides. Get ready for takeoff in 3, 2, 1. Ha! Yeah! That is the beauty of the tea bag rocket. So why did that happen? So how do all of these phenomena work? Let me know in the comments, or make a video explaining any or all of them. Or subscribe to the channel and I'll post the answers next week. I hope you enjoyed those fun physics phenomena. I know a guy who would, the former commander of the International Space Station, Commander Chris Hadfield. I'm actually hosting live events with him in late August in Sydney and Canberra. I am so looking forward to that. Now, the Sydney shows are all sold out, but there are still, as of now, tickets to the Canberra show. So if you want to come to that, check out the link in the description. Now, Chris Hadfield actually wrote a book called An Astronaut's Guide to Life on Earth. And I am listening to it right now as I travel around the world, and it is awesome because it contains great advice not only for people who want to become astronauts, but also for everyone who wants to lead a meaningful life here on Earth. And you can download this book for free if you like by going to audible.com/Veritasium, or you can pick any other book of your choosing for a 1-month free trial. Audible is a great service with over 150,000 titles in all areas of literature, including fiction, nonfiction, and periodicals. And so you can find virtually anything you want there. And by going to audible.com/Veritasium, they know that I sent you and they help me